Welcome to the SOFLUX webinar series. Today we have a community discussion to try and look at the proposed Antarctica InSync intensive observing effort and how that might address air sea flux questions. And so Alex Haumann is going to start by talking about the concept, and then we'll have a few other speakers. So Alex, do you want to take it away?
Sure. Yeah, so thanks everyone for taking the time to discuss this with me and everyone else. And yeah, I think it's maybe for some of you have heard about this quite a bit already, but I think it's good to have a very dedicated discussion related to air sea fluxes probably. And I think Marcel and a couple of others had it already at the SOOS symposium a little bit, but I think we can certainly expand on this and maybe take it a step forward in this discussion. So first of all, it's very important to know that this is a huge community effort. It's something that has been around in the community for a long time, and there's different initiatives coming from different directions that we are trying to now coordinate and bring together into one hopefully synchronized effort. The name that was given to this effort is Antarctica InSync. That was mainly given through through a letter that was submitted at the Antarctic Treaty meetings by a couple of nations. And well, I think it's a good name, but yeah, we seen more a little bit of where this is coming from now. So as I said, it's a very big community effort. There's different pathways that led to that, and maybe I'm not even listing all here. So there's certainly the UN Decade of the Ocean, Southern Ocean Action Plan that had this very strongly implemented in the suggestions to have a year-round effort in the Antarctic to specifically to look at winter, to get more winter data in the sea ice covered regions. And that plan is online, and I guess most of you are familiar with this. There is also the SCAR Horizon Scan that discusses this such an effort and has this implemented as well as a strategy, and then certainly there is larger community efforts that are trying to synchronize data circumpolarly in general, and have been working on this for a very long time. And these are, just to name a few, these are certainly SOOS. Also the ICE effort from an ecosystem perspective, and they also have implementation plans online that refer to such coordinated data collection efforts. And then certainly there is the development from the WMO and GOOS to have very consistent variable sets, which is called the essential climate variables or the essential ocean variables. And the InSync effort is trying to strongly implement that concept as well for the EOVs. So what came out of this is that we need year-round and circumpolar observations. We need an observing network that integrates ship-based effort, autonomous effort, remote sensing efforts. It should be multidisciplinary observations ranging from physics, biogeochemistry to ecosystem perspectives to probably also geological perspectives, sediments, and it should also integrate strongly modeling efforts and be informed also by modeling efforts. So what do we really need in terms of observations to improve our system models to do better in the Southern Ocean? And then we need unified measurements. We need to come up with protocols. We need unified variables, as I mentioned already. We need metadata systems and data publishing concepts that will be part of this InSync effort. And probably there will be developments over the next couple of years to prepare this for the effort itself. And then certainly overall, we need international coordination and initiatives, national initiatives that we can bring together to reach this goal. It's a pretty unique opportunity that we have here. SCAR just had implemented the Southern Ocean UN Decade Collaborative Center. And as I said, the InSync effort was submitted as a letter of intent by several nations. I think this list is growing to the Antarctic Treaty Meeting. And it's also going to be registered as a decade action for the UN decade. What is needed and what we should work on as a community over the next couple of years is the science planning and the fieldwork planning, and probably also the raising funding and coordinating our efforts. And that should come out of all the expert action working groups, whatever we have, the different groups that are around from the Southern Ocean community. I'm just listing a few, but there's many more that we need to bring together somehow. In terms of timeline, so 23 was basically to have communication, to spread the word, to have first workshops to see what science questions we want to address. Then 24 to 26 should be the detailed science planning, the preparatory phase. We hope that by the end of the year, we have a website and a mailing list that we can also have this all information collectively in one place. We are working on this right now. At the Alfred Wegener Institute, we will probably also have someone to do some coordination efforts, some management efforts, but we will have to think about this in more detail. Then the phase 27 to 29 is the fieldwork phase, the implementation, and then the 29, 2030 should be the completion and reporting phases. What are the scientific goals? And we had a workshop at the SOOS symposium, and I think in summary, the three main goals that we so far identified, it's not meant to be a complete list or a final list, so this is should be an iterative process. So one clear goal is to better constrain the Southern Ocean heat, freshwater, and carbon budgets. We should better understand related processes, and sorry, there's a typo, it's response to climate change as well. We should also better understand what's happening with the Antarctic sea ice right now. Why do we have such a rapid sea ice loss causes, but also the consequences, and that's something we have to find out in the next couple of years. What are the consequences for the ocean circulation, for the ecosystem? So there will be plenty of questions around this main topic. And then the third topic is more the coastal topic. So what is the role of the Antarctic slope current, and in terms of the transport of heat and fresh water on and off the shelf, and that's affecting the ice sheet and sea level rise ultimately. And all these three topics, they are interdisciplinary, right? So they all touch upon physics, biogeochemistry, the ecosystem. And all of them are meant to integrate ocean, atmosphere, sea ice, land ice, and also the sea floor. Some first suggestions regarding potential observational strategies. So this is mostly the oceanographic perspective I'm putting up here, because that was the discussion that I was in at the SOOS symposium. So we were pretty clear that it should be south of the polar front, because this is where we are lacking the data, mostly in wintertime. This is where we have disagreements in terms of carbon fluxes at the surface between different observational data sets. The models are doing very poorly. We don't really understand the heat budget there, and the freshwater fluxes neither. So this was one substantial point. Then these green lines are proposed hydrographic sections. It's not meant that this is fixed and we would do all of them, but it's potential hydrographic sections. So these are actually sections that were done in the past. So this is the prime meridian section that is always occupied by the Alfred Wegener Institute. Over here we have the A23 section that I didn't hit very well, sorry. And then there's the I6 South section, for example, We have P18, P16 sections. So these are repeat sections from GoShip and VOS. So if we occupy those during InSync, we can relate actually, if we build a climatology for this specific year, we can relate backward in time if we have data, which is, I think, a big advantage to also get a temporal perspective. Then the goal is also to deploy moorings. So these red dots are indicative of possible subsurface moorings, not surface flux. So this is something to discuss further now. So these are potential subsurface mooring systems that could be deployed to assess gradients, meridional gradients across the ACC and across the sea ice covered ocean and across the shelf break. And we are currently working at the Alfred Wegener Institute to test biogeochemical mooring systems of the upper ocean. So these will be tested in the next couple of years. We had one successful deployment already to have a more detailed upper ocean structure that also includes biogeochemical and biological measurements. So the idea is that we would expand on these and possibly have some more of this to also understand the upper ocean layer much better. So there is possibilities to repeat these sections over the year, depending on the availabilities of ships, the commitments of different countries. So we will have to see what type of sections we can do and how often we can do them, depending on what ships we will have available and who's committed to do what. Certainly, we should also expand that probably to sail drones, which I think have been very successful recently, and I think would be very beneficial for upper ocean processes, but also for AC fluxes. I think that's certainly a discussion we might have. Then in the sea ice covered region that is difficult to access in winter, to also have sea ice mass balance and the ocean and the atmosphere below and in the surface, there should be probably buoys that are deployed probably in the late summer season when the ice has melted and when it starts growing again, and then they probably drift out northward when the ice is growing, so we can have a full season in different regions of the Southern Ocean to look at those. Certainly, Argo floats will play an important role, animal tagging as well. So I think these are all topics that we should cover in terms of the oceanography. So that's all I have from my side, and I'm probably handing over now to Ronald, who also had some thoughts on moorings, but not the subsurface, but the air sea flux moorings, I think. So I stop sharing.
Great. Any questions for Alex while we transition?
I have a quick question, Alex. Hi. The sail drone discussion, obviously that's a referral rather to just general autonomous observations, right? Or is there any specific reason why you've highlighted sail drone there?
No, I mean, it should be all autonomous platforms, probably gliders as well. I specifically highlighted the sail drone because of the circumpolar capacity that we probably have with those. But certainly regional efforts, we have to talk more about autonomous platforms of how we can integrate them. I don't think there was a discussion yet, so that's why I haven't mentioned them or other autonomous platforms at the time. But this is something to also further discuss, I think. Yes.
Thanks.
Okay, so Ronald, you able to share?
Hello. See. Can make it?
It's starting. Yeah, and we see your screen.
Yeah, just to make it full screen. Well, good afternoon, everybody. Thanks for this opportunity. It's very quick. I guess I have only 5 minutes, so I'm just talking here in my name and name of my colleague Luciano Pezzi and the group here in Brazil. We've been doing some measurements on sea air fluxes in the Atlantic sector of the Southern Ocean for many years, especially in the northernmost limits of the Southern Ocean in the Atlantic, which is the Brazil-Malvinas Confluence. it's a very interesting area for assessing the importance of the strong sea surface temperature gradients that we have there in the synoptic cycle or modulation of the atmospheric boundary layer mainly. We do that using ships, but in the Southern Ocean, we've been doing and trying to do some good work using moored buoys. Because of the logistics the Brazil offers, we can only moor these buoys in shallow waters. So here in the first slide, you have an example of a buoy that we have deployed inside Deception Island in Port Foster Bay in 2013, so about 10 years ago. It was our first attempt to parameterize air-sea fluxes using moored buoys in Antarctica in that opportunity. Here is just a very quick glimpse of the works we've been doing using micrometeorological towers. They are actually mobile towers that we can mount in any ship. So we've been doing measurements using the track of the polar ships from Brazil to Antarctica every year. In fact, at this moment, people are at sea doing the same kind of measurements. We've been doing that since 1912. In 2012, so about 10 years ago as well. These measurements give us direct information on heat fluxes, sensible and latent, but also momentum fluxes and air-sea CO2 fluxes in this place. So we actually cover most of the areas between the subtropical front, crossing the subantarctic front, and the polar front when the ship comes from Brazil to Antarctica every year. This is an example of one of our recent papers where we cover mesoscale structures, and we have actually showed that these mesoscale structures, as you see here, a warm core eddy and a cold core eddy in the Brazil-Malvinas Conference, they have the power to modulate the atmospheric boundary layer just above them. So the influence of these strong gradients and mesoscale structures are not attached only to the surface of the sea, of the lower atmosphere, but also up to the limit, to the depth of the atmospheric boundary layer. So up to 1,000, sometimes more than 1,000 meters above sea level. We do not only track these edges and follow them with the ship, but we use altimetry and other satellite products to track them down and see the influence of them along or throughout their lifespans in the South Atlantic or in the Atlantic sector of the Southern Ocean. Here we have a deployment that we have done last year, in this case in another area of shallow waters in Admiralty Bay, King George Island. We have used these buoys with meteorological and oceanographic instruments attached to them, but also we linked these buoys to a SOFAR buoy to measure sea waves. Several variables linked to waves. And we have shown using our time series here that the variability of most of the atmospheric variables are the mainly drivers for the air-sea fluxes modulation. The two panels here in the bottom of the figure at the left-hand side show sensible heat fluxes and latent heat fluxes, and the red and blue bars that you see throughout the time series show that episodes of very high or very low heat fluxes are modulated not by the local sea surface temperature that is pretty much the same throughout the time series. You see here there's a small during about 3 months, a small increase of the sea surface temperature, but the modulation is actually made by the atmosphere advection patterns that you can see here at the right-hand side of the slide, whereas you see blue representing cold advection, or meaning cold air, cold and dry air coming from the interior of Antarctica, and in red colors you see warm advection that are representing air masses coming from South America or from the South Atlantic Ocean to Antarctica, and the modulation represented by the bars in red or blue show that the episodes of very anomalous heat fluxes are not modulated by the local impression of sea surface temperature, but by the large-scale patterns of the atmosphere, meaning for us that it doesn't matter where you put your buoy, either or in shallow or in deep waters, the signal that you have and the most of the variability is actually linked to the large-scale atmospheric processes, which means perhaps that it's easier and more costly effective to have these buoys in shallow waters instead of deep waters deployment. So thanks very much. And sorry for the rush.
Thank you. So did we end up with another speaker, or is it just me next talking about the satellite perspective, which will be really quick?
I think Simon maybe wanted to say some words as well.
Oh, good.
I think,
Yeah,
from,
good.
from
Let's
that
let
email
Simon
discussion.
go.
Yeah.
Yeah. Oh, and I have to make Simon a co-host.
You want me to go now, or do you want to go first, Sarah?
Why don't you go next?
Let me just give me a second to get my screen shared. Can you see? Are you seeing a PowerPoint?
It's coming.
It says it's paused. Now, why is that?
Oh.
Maybe because I've got another screen set up. Let me just do this for the wire out. Can you see anything now?
That's working, yes.
Good, okay. Let's just go with that. I won't, well, actually, I will play around with trying to make it full screen. Here we are. No, okay. Well, let's go with what you've got there. I just want to make the point. That's great, Ronald. I was really impressed by that presentation, and it's fabulous work you're doing there. It'd be great to get some more flux moorings in the Southern Ocean, wherever they are. So just background for people who don't really know. In terms of air-sea flux moorings, ones which are capable of equipped with radiation sensors, etc., there have really only been two what I would call open ocean deployments to date. The long-standing one south of Tasmania. I'm not sure if you can see my cursor or not, but
yes.
That's called the Southern Ocean Flux Station. And that's been in the water on and off for about 10 years, thanks to Eric Schultz at Bureau of Meteorology. And then there was the more short-lived 3 or 4 year deployment of the Ocean Observatory's initiative mooring upstream of Great Passage. Now, I've highlighted those on this plot, and also I've shown 2 grey boxes. This is from a paper I recently had in a special Southern Ocean issue of the Philosophical Transactions of the Royal Society. Lots of papers in there following a meeting in London last year. But it looks at this idea of heat flux asymmetry, which I think in terms of the surface component of the heat budget, the forcing of the heat budget of the Southern Ocean is the main factor we have. And that idea is that we have primarily heat gain in the Atlantic and Indian sectors of the Southern Ocean and heat loss in the Pacific sectors. And that idea has been around for quite some time. And in particular, Veronica Tamsit's done quite a lot of work on that very nice paper a few years ago. But the problem is that if you look at where the moorings are, we've had a mooring in the Pacific sector, and we've got this mooring kind of just outside this Atlantic Indian sector and at the limit there, but we don't really have anything at all which samples the Atlantic Indian sector. So I'm trying to argue when I can that we should be thinking about putting a mooring in somewhere here. Now, obviously, it needs to be deployed from somewhere, so that constrains us in what we're doing. And maybe it could be in shallow water, if that's possible with Brazilian moorings, but not in the deep ocean. But we need to think about that. I did talk briefly online with JB Saleh about this a year or so ago, and I'm seeing him next week in Paris for a European project meeting. And so one possibility is Kerguelen. That's just a possibility and nothing more than that. You could potentially deploy from there. Another possibility would be South Georgia and deploying from there. There may be other ones that are more suitable for you, Ronald. I'm not sure, but anything which will capture the air-sea interaction in this sector would be a really good start. I know we've got to try and get it for the sector as a whole, but we have no measurements at the moment, and so we need one measurement, one time series at least, just to get us started. And I think it's potentially useful because just show the other. I want one more slide. I've got. I'll show this one. So, what's special about this asymmetry? Why is it useful to us? Essentially, we want to know whether our coupled model representations of the large-scale forcing of the Southern Ocean are realistic or not. And also in this same paper I referred to that I had published earlier this summer, we did some evaluations. That in particular was Jenny Mecking at Southampton. I'll give her the credit for doing the CMIP6 analysis. So what you're looking at here is a plot of the heat flux in the Atlantic Indian sector on the x-axis and in the Pacific sector on the y-axis. And what you can see here is that in the Atlantic Indian and various reanalyses, so the colored bars here, you can see in the legend what they are. So era 5, I think, is the green one. But these are all clustered about this point, and they're showing that we have heat gain in the Atlantic Indian sector and close to heat loss, or close to zero or heat loss in the Pacific sector. But all of the CMIP models here are quite offset. They don't capture the Atlantic Indian gain at all. That's a strong offset of 20 or 30 watts per square meter. Now, why is that the case? That's something I'm looking into at the moment in terms of the different flux components, etc. But it's always a possibility that the reanalyses themselves are biased in some way, and we're lacking the time series, the point measurement. One point would be a start to enable us to say what's really going on in the Atlantic Indian sector. And you have measurements, and Sarah's worked a lot on this in the past, from collecting Drake Passage cruises, which are potentially useful to address this problem. But I think still there's an issue with getting a year-round time series, a multi-year year-round time series. That's what we really want. It's been very powerful at the SOFLUX site and at the OOI site, and they've been paid quite a few papers now, Veronica and Ivana Chervesky with Andrew Myers, looking at that mooring data, and that's given us insights into the sort of joint forcing of those two sites. So that's really all I want to say. It's just as part of this, I'm very pleased to see this this initiative developed. I think it's great, Alex and Ronald and Sarah, but just making a sort of plea to think about a mooring in this sector as part of it. Okay.
Great, thank you. Any questions as we change over?
Yeah.
Simon, hi. Can you speculate why the CMIP6 models are not representing this heat gain in the Atlantic Pacific?
Not as yet, no. It's something I'm working on, and I might be able to say more to you next week in Paris, but I don't have a definite conclusion as yet. It's a big task to try and pull it apart. So I wouldn't want to give the wrong impression here. Yeah.
Sounds good. Thanks.
One thing that we have noticed, Simon, about CMIP 6 is that because we are using obviously many Earth system models that have different parameterizations of air-sea fluxes, it's very difficult to compare them one to another. So that's one thing that we have to take into account, which kind of parameterization we have to do, perhaps using also wave.
This is part of the problem, yeah.
Exactly, yeah. Anyway, thanks.
Yeah, it's not an easy thing to do.
Are you seeing my screen in the correct mode?
In presenter mode, sir.
Displays. Is that better?
Yep.
Perfect.
Okay, so my goal was just to really quickly address what might be done from space. And as context for this, I think that OASIS has laid out a series of grand ideas for satellite or for air-sea flux observations that starts with grand idea number one, to do in situ observations, and that's a lot of what we've been talking about so far, but also to enable the capabilities for satellite observations of air-sea fluxes, which is what I was going to really quickly hit on today, and then thinking about linking that to improved models and understanding and providing access for stakeholders. So I wanted to quickly talk about what opportunities might be available for air-sea fluxes from space during the Antarctica InSync period. And that's a little frustrating. There are different variables you can imagine measuring from space. One is momentum flux. The European Space Agency has a program called Harmony, which will have multiple SAR satellites. Can you see my cursor? So an existing SAR system will have two satellites that look at it as well, look at the same spot as well, to get multiple looks to give direction for wind and currents. That's due to launch in December 2029. So that's sort of out of the Antarctica InSync observing period. Sea-Star was under consideration by the European Space Agency. I understand it's probably not going ahead. And Odyssey is a proposal to NASA with CNES support that, if selected, would launch in the 2030s. So these types of systems are potentially going to give us extra information, but maybe not in the observing period that's currently being planned. The other variable we'd love to see measured from space is air-sea heat fluxes. Butterfly was proposed to NASA as an Earth Ventures mission. It did well, and it will be reproposed in the next round, which I think, if selected, would get it flying in the 2030s. But that's an effort to measure near surface quantities and surface temperature and surface winds using passive systems. And so that leaves us with what we actually do have available for the time period that's targeted for Antarctica InSync, and that's winds. COVR is a passive system that's currently operating off the International Space Station, and the European scatterometers, the ASCAT and its successors, are likely to be available in providing winds. We're getting good sea surface temperature for the Southern Ocean, where it's always cloudy. Passive microwave sea surface temperature systems are really useful. Infrared SST, which has higher spatial resolution, is rarely able to detect anything because of cloud cover. And there are SAR systems that have the potential to retrieve wind and partial current measurements. And so that's what we might see available. It's probably less information than we might want to help knit a picture together, but it's potentially part of the observing system. So I think I'm happy to answer questions about any of that, but I think really we want to open this up for discussion to think about what, as a community, we might push on. Yeah, Alex?
Just a couple of brief questions or thoughts. So on the satellite missions, I think I agree. I mean, it would have been nice to have this during the InSync period, but also what the idea of InSync is that it's, a first step towards a long-term observing system that might be established in the Southern Ocean. So we want to, test different networks, different strategies, and certainly there will be a big effort on this here, but I think the goal is also to have something that's sustained and especially moving towards the IP-wide and in, when is it, 34, 33? I don't remember actually when it was planned, but I think that's also something to keep in mind when we talk about this. And
that's a really good point. Yeah, and I think if these satellite missions are getting launched in the 2030s, having a way to do CalVal for the satellites, having with instruments we believe in high sea state, windy conditions in the Southern Ocean would be invaluable for demonstrating the success of the satellites and for understanding how to knit that data into a global picture of air-sea fluxes. So there's a good way to paint a vision for this that doesn't require us to suddenly get satellites launched much earlier than they'll be ready.
The second comment I wanted to briefly make is that Felix Pithan at Alfred Wegener Institute, who unfortunately couldn't join today because he's on vacation this week, is planning to do a high altitude aircraft campaign during InSync. Also having a platform available for possible remote sensing instruments. So that's something to think about maybe as well, and something I wanted to add at this point.
Yeah, that sounds really interesting.
Can I ask a question? And this is an open question. It seems to me that over the last, few years, especially thinking about Matt's paper and with the decorrelation scales, Simon, your paper that's just come out with the asymmetry, the Way paper with the mooring placements, that the Southern Ocean is quite unique in the regionality of the fluxes. And yet there is a lot of work that's already being done collecting observations in these areas. But of course, there's also big holes and big gaps, as we know, across the Southern Ocean. And so I'm thinking in the context of, Antarctica InSync, does there need to be some sort of coordination of all of this in terms of understanding where the specific gaps are, that the lower hanging fruits are that we can strive towards, what needs to be gained there, what observations do we need to get, and yeah, I guess contact national facilities or I don't know, write a white paper on what is needed given all this new information. Is that kind of an effort required at this moment, or do you think that's a bit too far down the line? And that's an open question, I guess.
I think Simon's going to speak to this. Yeah.
I think that's a good point, Marcel. If there's a way to get much of what we could learn from a surface flux mooring from other platforms, enough to resolve some of these questions about the asymmetry differences between CMIP and reanalyses, for example, then that would be worth doing. If it turns out to be something which is related to representation of a near surface air temperature, for example, in the models, then we don't necessarily need a surface flux mooring to get that. We could probably get that from sail drones, I guess. But I'm not sure what the current thinking is on sail drones and capabilities, and whether that they realistically can tell us much in the Southern Ocean. I know there have been problems. What's your view on that, or anybody's view on that?
Yeah, I guess the first question is, where can you sample with autonomous vehicles in the Southern Ocean, given the logistics of ice and light? I know that even if you don't have ice and you have light deficiencies, it's really difficult to get autonomous platforms further south. So yeah, I'm not sure how we close that gap, if I'm honest. Yeah.
Then there are collections of research vessel transects or supply ship transects. Lisanne, you wrote a nice paper a couple of years ago now with Eric Schultz, and I was on that one as well, using the Australian supply ships. But you're restricted to certain periods of the year. Obviously, the better weather periods of the year. Whether we can push that data a bit further and learn something, I don't know. Whether we can push the Drake Passage data a bit further, it may be, it's certainly worth reconsidering. Because deploying a flux mooring is going to be a difficult and expensive undertaking. and we'd like to have something fairly soon for this initiative. I think, you know, what can we get from what we've got already, which we might not have extracted so far. Ronald, what's your thinking on the Brazilian deployments? I got, you know, from your presentation, I'm still not sure in, say, five years' time where you think you'll be in terms of mooring deployments. Do you think you'll be able to put one? I saw the Deception Island thing you referred to. Is it likely that you'll be able to put one out like that again for a significant period of time?
Yeah, Simon. In fact, in Deception Island, we had a problem of tracking the buoy after deployment because it's very high mountains surrounding the buoy. So it's not really a good place. But in the Admiralty Bay, which is very easy for us to go and come back, we have a permanent station there working throughout the year. And it's shallow water, so 18 meters, for instance. And we have ships, polar ships that are not specifically oceanographic ships. We don't have A-frames, for instance, for deploying buoys in deep waters, but we have the logistics to deploy buoys, big buoys in shallow waters, and they are quite easy to do so. The problem of funding in Brazil is that the projects we have are funded for about 3 to 4 years only, so we have to resubmit. At this moment, you're aware, we have submitted a new project to ProAntar. We're so hoping to have them. So we have money, if it's approved, to buy 2 other sets of instruments, including the buoys, to be deployed. And we have the opportunity to talk to you guys to see the better places to deploy them, and perhaps using other ships, not only the Brazilian fleet, and use them to deploy in more deep waters. I guess having a meridional set of buoys from, for instance, the Falkland Island, South Orkney Island, or any other one, up to the northern tip of the peninsula will be very nice. So we could have a meridional transect of what's going on. And we are pretty aware that the very high frequency changes in the atmosphere are actually modulating most of the differences in the heat fluxes between the ocean and the atmosphere. We are not actually, I think it's not actually wise to deploy instruments for doing micrometeorology, to have the fluxes computed from eddy covariance methods, because the anemomic sensor, sonic anemometer, tends to get frozen and wet in surfaces. So we rely on parameterizations. So that's other thing that we could talk together and get a better parameterization together with the proper instrumentation in these buoys. So there's plenty of things that we could think. And I think if you have an international effort with different ships from different countries, no matter if the buoy is Brazilian or English or New Zealander, we could deploy them everywhere as we have the logistics from these other Antarctic programs. So I think this is important for us to think about.
Maybe briefly following up on this point, that I think the advantage of this effort is also that, you know, the idea is that the ships are available to anyone from any nation, basically. So, you know, even though it might be a British cruise or a German cruise or a Brazilian cruise, right? And the idea is that we want to think strategically and have instruments that are or also people that want to go on expeditions to swap between ships depending on where we want to put instruments, and I think that is also the idea of this. So I think what you're saying is very very relevant and great for this initiative. And the second thing, following up from Marcel's point, would it be useful to have a white paper for, funding strategies to have like a very dedicated international white paper on. I mean, we were thinking to write one for InSync in general, but we could also think about splitting this up and having one for SOFLUXes and another one for other topics. Yeah, I think that might help also to generate more funding in different countries for such buoys, maybe.
Yeah, that makes a lot of sense. I was going to ask what the funding status is for InSync at this point. What's been pledged, and are there countries that are definitely committed?
Well, that is a difficult one. So I'm not sure I'm in a position to comment on this, because I mean certainly the letters at the Antarctic Treaty meeting are some sort of commitment by countries, also by different directors of different institutions, that certainly have a large interest to make this happen. But I don't think there has been yet fully committed fundings on paper, and I think that's something we have to work on in the next couple of years to make this happen. And I think as long as there is an overall larger drive, I think we should try to make the most out of it and get the most out of it, and we will see what we end up with in the end.
So it seems like there's a lot of room for a white paper that represents a community vision, with some side negotiations about what individual country contributions might be. On the US side, I could see, possibly fruitlessly, but in campaigning to try and get NSF support to, for example, redeploy a mooring in the OOI location, maybe using some of the capabilities of the OOI group. And that might not be fundable just in and of itself to say we should have something there, but if it were framed in terms of the sort of needing to fit 4 points around the system that Simon talked about, that might be a strong case. And so if there were a way to put together a multinational proposal and push the US for one thing and other countries for something else, maybe we'd get everything that the science and the model analysis implied we needed.
Yeah, I fully agree, and maybe this is nicely also integrated with the idea that Ronald had, that we have, first of all, we have a basically a zonal distribution that Simon talked about, but also this meridional transact that Ronald talked about, and I think these combinations could be very valuable, maybe. So yeah, it's a very good idea. Yeah.
So if there were to be a community white paper, what would the timeline need to be?
I'm not sure whether this is addressed to me or anyone.
Anyone.
So I don't know. So I know that for the SOOS symposium, there was a plan for a special issue that should be published at some point next year, where we might want to think about something like this, but it could be also detached from that. We have been thinking about this special issue regarding, a general overview for InSync. But if, we would think that, a more dedicated paper to RC fluxes would be needed, then I think this could go somewhat in parallel. Either way, I think would be great.
Alex, if you allow me, I just want to give a word to my colleague Olga here, because she is a coordinator in Brazil of a big project called SEMOC, which has instruments in the Atlantic from South America to Africa to monitor the Atlantic meridional overturning circulation is the instrument. So she can just speak for 1 or 2 minutes if you allow.
Yeah, go ahead.
Okay. Yeah. Okay. Thank you. I'll try to be very short. Basically, Ronald already said stuff that I wanted to say, but I'm here just to observe. But maybe I think when we are going to write about the white paper, it would be nice to have these connections and impacts of things that happens in the Southern Ocean with things that are just outside the region you are. And we have this array of inverted echo sounders at the 34.5 south. And at this location, we are trying to monitor the MOC, but also the changes in the interior of the ocean and the water masses. And at the place that we are, besides the upper layer of the upper branch of the MOC, we also are observing changes in the deeper part of the ocean. So we are trying to understand how, the amount of the Antarctic bottom water can be found in that location, and we observe that. So with this array that we have since 2009, so we see some of the warming patterns of the Antarctic bottom water, and we know that this water is coming from the Antarctica. So I think it's a nice connection to show the signal that we observe with the sea fluxes or the heat fluxes in the Southern Ocean, and then how it connects with, something that's much bigger, which is the MOC, the upper branch of the lower and middle. So it's really important, and maybe we can, try to connect this. And then one thing that Ronald mentioned here is that we are trying to maintain like a twice a year of cruises to go and do the maintenance of this the sea pies or the pies on the western side of the earth. So we are just taking care of the western part, which is a collaboration with it's us, Argentinians, and from NOAA, from Miami. So Renelli Perez, and she's leading that group. So we are trying to maintain that, but we have like twice or once a year a cruises that will go do the maintenance. And we don't go farther than 34.5, but if it could be used to deploy stuff or do some heat fluxes along the way we go to São Paulo, to that place. I think it's something that we can try to collaborate. And even we have other projects that are taking advantage of the array that we already have. So we have tall moorings from the UK and stuff. So from iAtlantic. Mission. So we can do some collaborations and use that array since it's already maintained. So we can try to use like a support for the things that you are doing. Okay, thanks.
Thank you. That sounds great. So I think we have about 5 minutes left. Are there other questions or comments people would like to bring up? Thoughts about what should be included as part of this?
Sorry, no, I'm just aware. I'm just wondering if anyone is aware of the use of wave gliders for air sea interactions in the Southern Ocean, besides that I know that work from Sarah Nicholson. But it seems in terms of autonomous vehicles, that could be potentially a good asset to think about. I know they are very expensive, but.
Yeah, I think there was some work by James Skirton and Jim Thompson that attempted to use wave gliders, and they got some data a number of years ago. It's definitely a good platform to look at.
There is a problem with the light, like the solar energy, because we did in the Arctic, and we did in September with the wave glider to do air sea fluxes and other measurements. And by the end of September, we have to get the wave glider in the ship and charge and put again and do again. So we couldn't let that like as an autonomous platform for 1 month. We did August very well, but September we started to have a lot of issues. So I don't know how it's going to be on the Southern Ocean, because of for recharge the wave glider on the winter time, as you get in the winter.
Yeah.
I was checking their website and it says they have an endurance of 1 year. So I was wondering if anyone had tried that.
No,
1 year
they
in
have.
sunshine.
No, yeah, they have. However, when you have no solar power, you may
Okay.
difficult to recharge it. So it
But
is
they
kind of
also are
environment.
wave powered, right? There's, I think, both.
They're wave propelled.
Yeah,
Okay.
wave
Oh,
propelled.
wave propelled.
Yeah. So they have this smallish.
Well, I think in the final 3 minutes, maybe we should articulate some goals as a community for how we might contribute to the Antarctic InSync planning, either through an independent white paper or through a few paragraphs to a white paper. And what do people think?
Well, what's the time frame for doing that? Do you think, Sarah? Month to
Alex,
month?
what do you think?
Well, we have
Well-
some material that we have already written, but we have the Oasis paper as well. Simon's one is quite nice. So we got a good start, I guess. And perhaps experience of what we have done should perhaps make a paragraph or two. But 2 months, perhaps.
Yeah, I mean, for InSync in general, I think we have a little bit a longer time frame for the planning, but certainly it should be in the initial part of the planning phase. So I think like anything that happens within the next year would be good. So if we maybe come up with a white paper in like half a year time, that I think would be good, and then it takes some time, and also for funding agencies, if there was proposals submitted, I think it should be rather early than later. So I think that like half a year or something might be a good time frame, maybe. And everyone certainly, with InSync, everyone is welcome to contribute anytime. We will have a mailing list, as I said. In the meantime, also feel free to reach out to me. I can collect email addresses and put them on the mailing list as soon as we have one. But I'm sure you will see if there is a website up at some point. Yeah.
Sounds good. So I think if there is a volunteer to at least collect a few paragraphs in a reference list, maybe from a SOFLUX standpoint, we can think of putting together just the bare bones and deciding whether that would be something that we would try and shoehorn into whatever Alex is putting together or release independently. Does that sound like the right approach? Alex is nodding, so.
Well, it sounds good to me, but I won't be the one that puts it together.
Well, I'm here if you want anything anyway.
Yeah, and maybe Ronald, since you've thought a lot about it, maybe you might start by just writing some bullet points that we could circulate around
Good.
within this community and just decide what we want to do.
Good. Okay.
I think the choices are to really write a full lengthy vision for what the future should be, or to say we can do this in a couple paragraphs citing some published literature, and we'll keep it short and fold it into the other documents that are coming out.
Okay.
So we'll leave it. We need to wrap up. It's the end of the hour, but we'll leave it that if people have immediate thoughts, Ronald is going to collect the bullets and get things started, and they could email him, and we'll move things forward maybe in a Google Doc that other people can add to.
Good. Thank you. All right.
Well, thanks everyone for a great discussion. This has been really interesting and useful, and really nice to think about what could be possible and how to address the needs. So thanks to the speakers.
Thank you.
Yeah, thank you everyone, and thanks for organizing this.
Very nice to see you all.